Hi everyone. So my name is Swati and welcome back to my channel. So today I am going to do my favorite topic. Personally, my favorite topic is derivative, okay, differentiation. So yes, I am going to teach you a very interesting thing on derivative. Uh, Basically, I'll just explain, okay, I'll share my screen and I will explain what I'm going to teach you. So yes, I hope my screen is visible and let us start. So I hope you have heard about this rule. Okay, this is a very famous rule in, you know, in derivatives, right? So this is called product rule. Okay, so I'm going to teach you about this product rule, how you can solve product rule questions very, very easily. All right. So first, I'll just tell you like how we can solve product rule. What is the formula? Okay. So let us write down the formula first. And yes, so if I'm taking, suppose we are having two functions, u and v. So we are going to write down the product of two functions, and the two functions are u and v. That means u into v. Okay. And what is the formula to solve the product of two functions? So the formula is we have to keep any one function constant and we have to do the derivative of the other function and the same thing again. So it's like here I'm keeping first u constant and doing the derivative of the second function. So this will become dv dx, okay? And plus, okay, because that's the formula, we are now going to keep the second function constant, which is v, and we are going to use the, like, we are going to do the derivative of the first function, which is du dx. Okay, I hope you have noticed that I'm not reading these two as dv upon dx, du upon dx. No, because that is not correct. We have to read it in a correct way, and the correct way is dv dx, du dx. All right. Yes. Okay, so this is the formula that we are going to use. So let us highlight this formula, okay? So yeah, this is the formula that we are going to use, all right? Now, you know the formula now, so let us directly take one question and let us solve, okay? Let us understand how we can solve product, like how we can apply product rule and how we can solve questions on product of two functions, okay? So for that, I'll just take one question. Give me a moment. I'm just choosing this color, okay? Yes, so let us take one question. And the question is, what is the derivative of, that means ddx of, the question is x, okay? It's not x, e raised to x, exponential function, and then cos x upon x cube, okay? This is our question. We have to find the derivative of this function, okay? All right, so let us start with the solution. Okay, I'll make you understand in a best possible way. Yes, and do let me know in the comment section if you have understood it properly or not. If you want me to make more videos on derivative topics or questions, please let me know about that. Okay, and don't forget to watch this video till the end, okay? Because if you are understanding this question, understand it till the end, right? Okay, so yes, now we can start with the solution. So first of all, you can see that here we are not having the product of two functions, right? You can see that there are some functions in the numerator and one function in the denominator. That means you can say that how can we use your product rule, right? We can use your quotient rule. The quotient rule is another rule. And on that topic, I'm going to talk in the next video, all right? So yes, I'll tell you how we can convert this as a product of two function and how we can solve it. So here what I'm going to do, I'm going to write down this as it is, ddx, and then e raised to x, cos x as it is. And now I'm going to shift this x cube, which is present in the denominator, in the numerator. And how we can do that? Using exponent property. So this will become x raised to minus 3. Now, why is it minus 3? Because the property is if we have 1 upon a raised to m, that we can also write down as a raised to negative n. Okay, so this I hope you already know, one of the properties of exponent. Yeah. Okay. Now you can see that we are having product of three functions. Still not, we have not reached to two functions, because here we saw that we are having the product of two functions. It's not like you cannot solve a product of three functions. You can also solve product of three functions, okay, because the formula will be same. But here I'm going to explain this question using product of two functions only. All right. So what I'm going to do here is I'm going to consider this as u. Okay, I'm just going to use another color for this. Yes, so I'm considering this e raised to x cos x as one function, which is u, and I'm considering this as another function, which is v. And now we can use the formula. Okay, we can use the formula and we can solve it. So what I'm going to do, I'm going to keep u constant. Okay, so that means I'm going to keep e raised to x constant. Yes, using the formula. Yes, and then we are going to do the derivative of the second function, which is x raised to minus 3. Okay, it's not like you can like you have to start by keeping u constant and doing the derivative of v. No, it's not compulsory. You can also start by keeping v constant and doing the derivative of u, because you will be getting the same result. So, and now we can write down this as the second function constant, that means v constant, which is x raised to minus 3. And we will do the derivative of the first function, which is e raised to x cos x. All right. Yes. And now we can solve this. So this will become e raised to x cos x as it is. And here we can use a formula to find the derivative of this function. So what's the formula? Let us write down the formula. So formula I'm writing here. Okay. So the formula of derivative of x raised to n is n into x raised to n minus 1. So using this formula, clearly you can see that here n is minus 3. So that means that minus 3 will come before x, and then this will become x raised to n minus 1. N is minus 3, so minus 3 minus 1 is minus 4. All right, and then we can move ahead. So again, here we can use a property of exponent. We just want to get rid of this negative number, so we can also write down this as 1 upon x cubed using the same property which I had written before, which I had written above, the exponent property, right? And then derivative of, we have e raised to x cos x. Now you can notice here that we are again having a product of two functions, e raised to x cos x. So let us assume this as u, okay, and this as v. You can take vice versa as well. So assuming this as u and this as v, again we can use for our product rule, right? So using product rule, of course, this will become, if I keep u constant, that means e raised to x constant, we have to do the derivative of cos x. Now, what is the formula of derivative of cos x? We all know derivative of cos x is negative sin x. So using this formula, we can skip one step here and we can directly write down here the derivative of cos x, which is negative sin x. So negative sign I'm writing here and then sin x here. Okay. And then using the formula, the sign is plus, so plus, and keeping now v constant, that means cos x constant, we have to do the derivative of an exponential function. You know that derivative of exponential function is same, right? It does not get changed. So yes, derivative of e raised to x exponential function is exponential function only. So that means this will become e raised to x. And then we can close the bracket. And now we are almost done, right? We are just simplifying our final answer. And yes, we can write down in like this expression in more simplified form. Yes, so let us do that. So here we can see that here we have minus 3. So let us write down minus 3 first, and then e raised to x cos x. Again, here we can use our exponent property. We can write down this x raised to minus 4 as upon x raised to 4. And here, if I just remove the bracket, so this will become minus e raised to x sin x upon x cube, okay? Because we have removed the bracket, so we have to multiply this 1 upon x cube with each term that is present inside the bracket. And this will become plus into plus plus, and this will become cos x multiplied e raised to x upon x cube. Now we can still simplify it further. So let us do that. And let me change color now, okay, so that the video will be interesting for you. So yes, if I just take an LCM of x raised to 4, x raised to cube, and x cube, of course, what is the LCM? You know that. I don't need to teach you the LCM. So LCM will be x raised to 4, right? So yes, we can write down here x raised to 4, and this will become minus 3 e raised to x cos x, and this will become minus x cube into x will be x raised to 4, so that x will get multiplied here. So x e raised to x sin x, and here again x into cos x, or we can write on x into e raised to x cos x, right? Now just two more steps, okay, just two more steps. So we can just write down this as if I just take here e raised to x common, because you can see that e raised to x is present everywhere. So we can just take that e raised to x common, and now we are left with, I'm just writing the positive part first, okay? That will not make any difference. So yes, x cos x, that means I have taken this part first, okay? And then here also this is cos x, like this is in cos x. So we can write down this now, minus 3 e raised to x cos x. And the last term is this, which is minus x e raised to x sin x. And then we can close our bracket, and then upon x raised to 4, of course. And we are writing our final step, because still I can see that I can take this cos x common, right? So the last and the most simplified form we are getting here. So if I just take here cos x common, so this will become x minus 3. Okay, I have done one mistake here, basically, because e raised to x is already common. So yes, I'm not supposed to write down this e raised to x again. So let us do the correction. Yeah, yes, now it's correct. Okay, so now we can just write down, yes, we can, because we have taken here cos x common, so we are left with x minus 3, right? X minus 3. Yes, x minus 3 only, because cos x is common. And then we have a minus x sin x as it is. And this is our simplified form. Okay, so yes, we can just write down our final answer like this. Okay, we can just make it beautiful so that it will look beautiful, so that you can see that, okay, yes, we have finally reached to our answer. And yes, that's the answer. So that's the end of the video, and I hope you have understood what I, like, how I explained and what I explained. Please tell me your feedback. Like, please, you can just let me know whether you have understood this or not. And yes, I'll be happy to read your comments. So see you next time, and bye-bye.